Great guys, so we're off again today. Notice I got a new laser pointer here. So our review today is for 11.5 to 11.7. This covers volumes and surface areas of solids, spheres, and then also our similar solids theorems. These are some must-have formulas that you absolutely should have written in your notes. You should have the volume and the surface area of a sphere in your notes. You should also have the volume formula for a pyramid, and you should also have the volume formula for a right circular cone or a cone. The pyramid formula might look a little bit different. We used it in class as 1/3 capital B times H. That was 1/3 the area of the base times the height. Remember to find the area of the base to multiply the two sides by each other. And then volume, you should be used to seeing. A lot of those are written as divided by 3 instead of times 1/3. It's the same outcome, just a different way of looking at the formula. So the first one that we're going to do today is finding the the volume of pyramids and cones. So I have one pyramid and one cone here that we're going to go ahead and find the volume of. So I'm going to switch over to the whiteboard and see how that goes. So our first problem here, you'll notice, gives us a pyramid. It has a square base and then a height of 18. It asks us to find the volume of that. Looking back to the formula sheet that we had from the first slide there, tells us that to find the volume of a pyramid, we take the area of the base times the height and divide it by 3. So I'm going to go ahead and use my volume equals area of the base times the height divided by 3. Remember, this sometimes can be written as capital A also. So area of the base times the height divided by 3. If you look at my diagram over here, the area of the base is 10 by 10. So that should be 10 times 10 for the area of my base times my height, which in that one you'll see is 18, and then divided by 3. And plug that into my calculator, or do it in my head. 10 by 10 is 100 times 18 should be 1,800 divided by 3. When I divide that out, it should give me an even 600. And I always go back to make Carol happy and keep the units, so I'm going to use cubic centimeters because we're talking about volume and we're also talking about centimeters. So that should be the first one for us today. You guys can see next is our cone. It's a regular right cone. It has a radius of 8 and a height of 18. So I'm going to go ahead and use my volume formula for a cone because I'm finding volumes. So my volume is a pi times the radius squared times height divided by 3. So I'm going to go ahead and do that. Pi times the radius squared times the height. The whole thing is divided by 3. We'll go ahead and plug that in. I've got pi, which I'm going to leave as pi in this case. The radius I'm going to plug in as 8 off of our diagram. We're going to make sure that we square that. And then lastly, we're going to multiply by the height, which off our diagram was 18. I'm going to take that whole answer and divide it by 3. Since I want to leave that in terms of pi, I'm just going to ignore it for right now and go ahead and get the rest of the math done. I have a cheap calculator instead of a nice one, but that's alright. So 8 times 8 will give me my 8 squared times 18. Should give me 1152 pi over 3. So 1,152 pi over 3. I'll go ahead and see if that'll reduce down to 384. Now, if the directions, it's a little better, if the directions asked me to leave it as an exact value, I'd leave it as 384. If they asked me to round it, I would round it to whatever number of places that they wanted, and I would get an answer of roughly 1,206.37. So I'm going to go ahead and round that to 0.4 to the nearest tenth. And then I would take that and put it into my units. Again, I'm dealing with centimeters, and they're cubed because we're talking about volume. Great, guys. Next one would be a type of problem that asks you to find the surface area and volume given a sphere. And you can see our sphere right there on the screen, and you notice that its diameter is 4 meters across, which means that its radius is half that. So we have a radius of 2 meters. Now, after we go through, we're looking first for surface area and then for volume. I'm going to go back to my reference sheet, and we'll notice that surface area is 4 times pi times the radius squared. So I'll go ahead and fill that in. Surface area equals 4 times pi times the radius squared, which gives me 4 pi times 2 squared. 2 squared is 4, so 4 pi times 4, 4 times 4 is 16, so 16 pi is my exact answer. If I'm looking for an estimate of an answer, I can use my calculator, and I can take 16 and multiply it by pi, and then round it to 1/10 of a decimal place, and I should get 50.3. And then my original units were in meters, so I'm looking for surface area, so I know that I have square meters. Next, it would ask us to find the volume of the sphere. So that same sphere again. Our radius is staying the same at 2 meters. We can go in and take our volume formula. Volume is 4/3 pi times the radius cubed. Again, 4/3 times pi times the radius, which was 2 cubed. Sometimes people ask me why sometimes I leave pi in parentheses or out. It just kind of depends on if I want to make sure that I break it up. So we're going to clear that out. I'm going to do the math easily in my head. If you guys haven't used it before, you can use your 2, and then the caret key will mean, try that again. You use your 2, and then this caret key will mean raise that to the exponent of 3, which gives us 8. I'm going to multiply by 4/3, so multiply by 4, divide by 3. Should get 10.66 pi. And then if I want to make that an exact answer, I'm going to go ahead and take that answer and multiply it times pi. And I'll get 33.5. And my original, again, was in meters. I'm looking for volume, so I know that's in cubic meters. Okay. Remember, leaving it in pi format is the exact answer, and then multiplying it out is the estimate answer. So this next problem asks us to use that ratio that we know already, which is that if there are 2 solids which are similar and they have a ratio of A to B, the ratio of their corresponding areas is A squared to B squared, and the ratio of their corresponding volumes is A cubed to B cubed. So when we're looking at these, this first problem asks us to find their ratio value. So what is the ratio from one to the other based on their surface areas? So surface area we know is squared units because it's an area. So we know that we have an A squared to B squared. And then we're looking for the volume, or excuse me, the ratio of one to the other. So when we're solving for that, we simply take the 1960, and we have that is equal to A squared. There we go. And then the other is the 961. Both of those are squared, and so we need to square root them to find our ratio. So when we take 1960, when we take the square root of 1960, that was not square root, of 1960, we should get 44.27. And then we should take the same with the square root of 961. We should get 31, which tells us then that the ratio of these is 31 to, excuse me, we want to put the larger one on top because it was given first. So we want this to be 44.27 to 31. I'm going to go ahead and divide that out. And I can leave it as a 1.3 ratio. So that should be pretty simple and straightforward. They also might ask you to do the same with volume. And the only difference being in that instance, as we work through, we would want to take the cube root of both sides where we took the square root on the last one. And then lastly, you guys should all be ready for your test. You can work this one out if you have questions on it. The last thing I wanted to leave you guys with is just a little bit different view. We might be used to seeing the pyramids in Giza, which is in Egypt. And all of this pyramid and solid work made me think about this. But what a lot of people don't realize is that the city of Cairo itself is right up on the edge of where those pyramids are. So good luck on your test.